Today, the student will be able to rearrange a system of 3 equations in order to write them as a matrix. So all we're doing today is we're going to learn how to build an augmented matrix. An augmented matrix is a matrix whose elements, so the things inside the matrix, are the coefficients of a set of simultaneous linear equations with a constant term of the equations entered in an added column. So here's how you set up your matrix. We're going to do systems of 3 equations. So you're going to have one equation be on one row, another equation on another row, and the third equation on the last row. So 3 rows in your matrix. Columns. There's 4 columns in your matrix. 1 column for the coefficient of x, 1 column for the coefficient of y, 1 column for the coefficient of z, and 1 column for the constant or the answer that you have at the end of the equation. If the elements in the matrix, so if the matrix is made up of coefficients, that means that nowhere inside of your matrix you're going to have any variables. In other words, no letters. Okay, now you also always designate a matrix with these brackets. Basically, a matrix is just a way that we can, it's just something that's used to house multiple equations in one spot. It's just another way of organizing your data. And sometimes when you have lots and lots and lots and lots and lots of data, like a 3x3, 3 equations, 3 variables, that's not a whole lot of data. But if I had a ton of data, a matrix gives us a much easier way to handle that massive amount of numbers. You won't see anything above 3 by 3 or 3 by 4. But when you get into college, you'll see larger matrices, and you have to deal with larger amounts of numbers at one time. So that's kind of the idea. All we're going to do today is build them. So if I give you the 3 equations, 5x plus y minus 4z equals 23, x minus 7y plus 2z equals 4, negative 2x plus y minus 10z is 12. You can represent those 3 equations as 3 equations, or you could represent the exact same data as a matrix instead. So in order to build our matrix, we're going to use brackets. We're going to use this first equation is going to give us our first row. The coefficient of x will be first, the coefficient of y will be second, the coefficient of z will be third, and then our answers will be after this line that we create. That's why it's an augmented matrix. If you see that line, it's kind of separating where the equal sign is at. Okay, so only the coefficients, no letters. So the coefficient of x in our first equation is 5. The coefficient of y in our first equation is not shown, but there's really a positive 1. The coefficient of z is negative 4. The solution, or the constant at the end, is 23. The next row is for the next equation. The coefficient of x is not shown, but it's 1. The coefficient of y is negative 7. The coefficient of z is 2. And the answer, the constant at the end, is 4. And our last equation, so our third row, the coefficient of x is negative 2. The coefficient of y is not shown, but it's really a positive 1. The coefficient of z is negative 10. Equals, I don't know why I have this extra line here, 12. Oh, that was a z. Sorry, I erased it. That was a z. Equals 12. Okay. That's it. That's all we're doing today. Now, the difference in question 2 is we're missing some letters in some of our parts, but it's okay. They're really there. You just can't see them. So if we're going to put the system into a matrix, this first one, remember we've got x and y, then z, then the answer. So let's build a spot for our answer and put in our brackets. All right, so x on the first equation is 4, y is negative 4, z is 2, the answer is negative 14. The second one, x is 4, y is 2, z is not there. There are 0 z's in this second equation, so we use the placeholder 0. The answer is 14. And the last one, there are no x's. there's a -3 for y, and a 1 for z, and a -10 for your answer. So if you're missing a value, make sure to put a 0 placeholder. All right, the last equation. If you look at this one, you need to notice that your things are not in order. Before I can take this first equation and put it into a matrix, I need to put it in the order x, then y, then z, and then just a number or constant on the other side of the equal sign. Right now I have 3x plus 4y equals 2z minus 40. Well, before I can do anything with this, I need the 2z to move over to the other side. So minus 2z. So I have 3x's plus 4y's minus 2z's equals -40. That I can put into a matrix, okay? So that's row or equation number 1. Equation number 2 says that 2x minus 10y plus 3z equals 5y plus 2. Okay, well, I need to move over the y, so minus the 5y. Now, I have y's on the other side, so I can combine those. So keep the 2x's, -10y's minus 5 more is -15y's, plus 3z equals 2. So that's my second equation. The third equation, 3x minus 7 equals y plus 4z. So I need to move the y, but I also need to move the 4z. So now I have 3x's minus y minus 4z minus the 7 equals 0 because I took everything away. But I need to add the 7 because it needs to be on the other side of the equal sign. So 3x minus y minus 4z equals 7. Okay, so that's our third. All right, so if I'm going to build my matrix, I'm kind of running out of room. The first equation is going to go here. Okay, so my first equation has 3 for x, 4 for y, -2 for z, and -4 is the equals. My second equation is going to go here. It has 2 for x, -15 for y, 3 for z, and it all equals 2. My third equation is going to go here. I've got 3 for x, -1 for y, -4 for z, and it all equals to 7. So again, all you're doing today is taking the equations that you're given, rearrange them so you have x and then y and then z and then an answer, and then put them into a matrix. That's it.